Hello, and welcome to the GPK Training Center. In the next few minutes, we're going to be taking a look at installation procedures for GPK fittings that, if followed, will reduce fitting failures. We're going to show you some in-the-field footage that demonstrates the right and wrong ways to install sewer fittings. We'll also utilize animated demonstrations to show you what occurs when proper installation procedures are not met. So, let's get started. The four main areas we'll be looking at today are bedding of pipe and fittings, vertical risers, axial joint deflection, and backfilling practices. The fittings that are subjected to the most stress on a job site are the T, the TY, the Y, and the elbow. For our demonstration purposes, we're going to be utilizing only the Y and the 45-degree elbow, although the methods discussed today are valid for all types of fittings. Now let's take a look at a visualization of a typical installation site. Keep in mind that riser sections connecting two GPK fittings will be various lengths from the main line. We recommend following ASTM standard D2321, standard practice for underground installation of thermoplastic pipe for sewers and other gravity flow applications, and the Unibel Handbook of PVC Pipe Design and Construction for proper installation. The stresses on fittings can be equal at any depth, regardless of how deep the trench is. Almost all fitting failures can be traced back to this critical step in the installation process: inadequate riser installation. So let's take a look at the bedding of pipe and fittings at a job site. Here you can see GPK fittings with a Y branch coming off at 45 degrees. It is at this point where proper installation must be done in order to avoid future system failures. The first step is to always provide a solid foundation under the mainline pipe and fitting. The main point of this support is to prevent the pipe and fitting from settling. If that happens, it can change the angle of the attached riser pipe, putting added stress on the fittings. It's important to understand that pipe and fitting must connect in true alignment in order to maintain the integrity in the system and reduce stresses. As you can see in this animation, if the mainline fitting settles, the angle of the riser pipe, which is embedded in the soil, causes pressure on the fitting, creating a break and system failure. The best bedding for pipe and fittings is always undisturbed soil. But in the event that is not possible, properly compacted fill of various types can be effective, as prescribed by the design engineer or the specifying agency. Local conditions may call for concrete pads and even encasement of the entire connection, pipe, and fitting in concrete. After the mainline fitting and pipe has been secured, the next critical area is the grade of the trench wall upon which the riser pipe will be laid. If the sidewall is not cut to grade to allow the riser to be laid firmly against undisturbed soil, differential settlement may occur later, leading the riser to transition from vertical to horizontal, causing more downward stress than the fittings are designed to withstand. In these situations, additional engineer designs are necessary to reduce the chances of system failure. Now let's take a look at what is referred to as a true vertical riser, which is the source of the most problems and failures. A vertical riser may be defined as any rise that exceeds 45 degrees from the horizontal. This type of installation puts more stress on mainline fittings than any other type of installation. Remember, vertical riser installations should not be used unless some special design structure accompanies the installation. Before we show you some tested designs for stabilizing a vertical rise installation, it's important to understand what occurs if these special measures are not taken. Here's a vertical rise installation with a rise angle of 85 degrees. As you can see, even under no earth load, the weight of the pipe is stressing the fitting. Now let's backfill the installation without proper compaction and see what happens. The trench in this example has been backfilled without the proper compaction. With no additional stability designs built in, When the horizontal pipe coming off the vertical riser is laid on disturbed soil, the earth settles and drags the riser pipe downward with it. This results in overbelling, joint distortion at the mainline joint, and even driving of the riser pipe deep inside the fitting itself, breaking the fitting and causing a system failure. Now let's explore a way to help stabilize a vertical riser that is proven to be effective. Heavier wall-to-solvent weld branches on main body fittings have been effective in stopping drag down, which overbells fittings, causing them to break. Also, backfill material, which compacts easier, such as sand and P-rock, etc., and does not adhere to the pipe and fittings, can ease drag-down forces on riser pipes. Perhaps the best way to avoid drag-down joint breakage is to use deep socket fittings, which are designed to accommodate pipe movement. As you can see in this animation, with deep socket connections on both ends of the vertical pipe, drag down simply moves the pipe deeper into the fitting. Also, remember to never attempt to adjust or bend a pipe in the manner shown here. Instead, use the recommended technique for adjusting a pipe's angle that is demonstrated here. The next area where problems occur in sanitary sewer installations is axial joint deflection. This often occurs when a Y is used at a service branch with a 45-degree elbow attached. Let's take a close look at the problem this causes. First, we attach the 45-degree elbow to the mainline Y fitting, which is at its proper 45-degree angle from horizontal. We then attach the service line and rotate it to make the desired 2% grade. As you can see, this deflects the service line, which puts it out of alignment to the connection at the other end. Problems then occur if the service line is pulled over to meet the connection. This places stress on the joints at both ends of the service line. The solution to this situation is to add another 45-degree elbow at the main line fitting. As you can see, this additional 45-degree elbow will allow you to move the service line to its correct 2% grade, without the deflection, which misaligns the service line to the other connecting point. It should also be noted that the same problem in vertical installations can be corrected in the same manner. GPK cannot stress enough the importance of proper backfilling and compaction. A general rule would be that, starting at the bottom, the levels of fill should be closely spaced or layered, then compacted to allow for proper support. Then gradually increase the amount of fill added per layer of compaction until the trench is filled. GPK recommends that backfilling be done in 6-inch increments and hand-tamped. Although this sounds a bit costly, redigging and repairing a failed line will cost much more. Sewer fittings are generally the highest stress points in any sewer system and are often expected to take the most abuse. This video was made to show some common problems during installations. Some or all of the techniques discussed here may prove helpful in avoiding system failures. Installers need to use common sense, previously proven techniques, and engineering expertise to keep failures to a minimum. For a complete guide on sewer system installations, see the Unibel Handbook of PVC Pipe and the ASTM Installation Standard D2321. These books contain more detailed information on various types of installations. From all of us at GPK Products, thank you for watching.
To contact GPK Products Inc., email info@gpk-fargo.com or call 1-800-437-4670.